Hello, my name is Dr. K.T. Ko. Today I would like to give a talk about a very topical subject on virus infections, especially effects of a false positive. What are the implications? The implication is telling you, for example, if you have test positive, that means you are infected. Should you really believe it? Okay. The second implication I will look at today is the possibility of having a universal test. Is it worthwhile? Is it cost effective? Okay, so those are the subject of today's talk. All right, so move to the lecture material, and okay, this is the lecture material, and I will look at telling you what is the when you do a virus test or any test for disease, you are either receive result positive or negative. Now, what's positive? Because they are testing for a particular virus or disease, and therefore that positive means you are actually infected. So you are positive in this case are infected, and negative means the virus does not did not detect it. So in fact, you are healthy. Okay, and if the accuracy of the test is 100%, then that's it. Okay, you're either infected or positive or negative, which is mean you're healthy. But unfortunately, we have test accuracy of less than 100%. For example, 99% is often be cited. Okay, so when it's the case, then the inaccuracy show up as a false positive. Now, false positive means that you are actually healthy, but the test tell you you are infected incorrectly. Okay, so we are looking at the effects of this false positive. And of course, there's also majority of cases true positive because the facts that not necessarily majority, but depending on the infection rate, and the true positive means you are infected correctly in the case. Now the inaccuracy why there is many operation problem, and one of the operation problems is because the testers have done probably hundreds of tests a day and he or she may be distracted, and then put the cotton bud deep inside your nostril or your throat in order to get the correct samples. That's one reason. The second reason is maybe the chemical used for the testing didn't put in enough concentrations of it. So that may be that problem. So the inaccuracies often happens. Now, to answer the motivation today is answer the question, if I have been test positive, should I be worried? Should I believe it? Okay. In fact, I will show you that will very much depends on the infection rate. Okay. And the concluding remark, we will look at the case of universal testings. So let's move forward. And in this in this talk, we will be using the data from ABC site in Australia, and in fact, it done very good data. We look at it, give us the 7-day moving average on a particular day. The day I chose is 4th of August because it was the latest when this note was taken, and the one I use is new cases versus test numbers. Now, I will look at the case for new cases over the entire population later on. So new cases worst test number is about 500 new cases on that particular day, 4th of August, on a 7-day moving average, about more than 42,000 tests. Now, the tests are done in the test center. You drive in, and you're given the test. So the people who drive in either have some symptoms or they are in close contact with confirmed cases. Okay. As I mentioned, the test accuracy is we often use is about 99%, which means there's only one error out of 100. Now, if we improve the test accuracy, that would be even better. But just assume this is the case, and then we will see what happened when we improve it. Okay. Now, the question, as I mentioned, if my test result is positive, should I be worried? Okay. Now, there are two methods to do it. One is based on conditional probability, on Bayesian theorem, that probably requires more understanding on the probability theory. So I will look at more intuitive way, the spanning tree solutions. Now, spanning trees means they are different outcomes on the effects of the test. There are 4 possible branches. Okay, the one is the true positive. That means you have been infected, unfortunately, and you test positive. Okay, and the other one is true negative. You are healthy, and the result come back to tell you you are negative. So they are both of them are good. Now, because of the accuracy is not 100%, the inaccuracy turned out to be about 1%. So 1 minus 0.99, 0.01. This shows up as a false positive. What's a false positive? That is the case when you are test positive, but you are actually healthy. Okay, because you make mistakes. You are healthy, at least you come back negative, but unfortunately, because of mistake, you show up as a positive. So we call that false positive. On the other hand, the false negative. So you are actually infected, but the test result is incorrect. It just tell you you are negative. Now this is the case where the test subjects miss out on the treatments necessary. Okay. Now the probability of each of the branch can be calculated. So I will show you how in the next slides. So remember this, the infection rate per test is about 0.0155. Okay, so let's move forward to the next things. Now, as I mentioned, there are 4 possible branches, and this is the case of infected, the subject being infected, and the percentage of this is 0.0155. And the test subjects are infected. They are gone through a test, and there are only 2 possibilities here. That is, the test is correct, 0.99%, and that is called true positive. And the other possibility is the subjects tested are having error, 0.01, and that is show up as a false, as a negative, but because it's an error, so it's a false negative. So what's false negative, I'll show you, is the person actually infected, but the result tell them is negative. So it's incorrect. Now, the other branch is the person is actually healthy. Okay? And the amount of this is 0.9845, just the one complement of 0.0155. And again, there are two also branch from this. Your test is accurate, 99%. Your test is have an error, 0.01%. And when it's accurate, then it's true because the person is healthy, that's true negative. When it's in error, then it show up as a positive. But it's in error, so it's a false positive. We will look at the effects of this volume. Okay? And in each of the branches, we could look at the calculated possibility or probability. Now, in this case, it's just multiply 0.0155 by 0.99, and you should get 0.0153. Okay? And true negative is if you just 9845 multiplied by 99, and that is equal to 94747. Okay? And the false positive is 0.984.01, which has turned out to be 0.0099. Okay? And the false negative, which is the unfortunate case where the patients, the test subjects are infected, but is not show as infected. So the show is negative, and he or she may miss out on the treatments necessary. So that is, but it's very fortunate there's only very small numbers of this case happens. So those are the four possible branches. Each of them have a probability associated with it. Now we will look at the effect of those relative probability on the implications we have mentioned. So we look at the proportion of tests shown as positive, that including false positive and true positive. And they are, just add those two branches probability together is about 0.025. Okay. Now, if my test is positive, so I go in and my test is positive, what is the probability I actually infected? Which is mean the proportion of true probability, a true positive. So I'm just a true positive, and over all the cases are positive. So this is a probability of getting infected, actually infected, when the test is positive. Given the test is positive, what are my probability are actually infected? And it turned out to be about 61%. Now, this, should you be worried? In fact, you should, because it's quite high. It's higher than 50%. So the probability, in fact, is quite high when test positive in Victoria on the 4th of August. Now, why is this? Because at that time, the Melbourne, Victoria, is in the second wave of the pandemics. And the tests are from people who have, as I mentioned, who have symptoms or possible close contact with confirmed cases. Okay? So with that reason, and the probability of them being infected are relatively high, given that is also in the pandemic situations. So let's look at a different case. This is the case of New South Wales. New South Wales is the state next to Victoria, and because of the virus in Melbourne and in Victoria, and the border has been closed. As a consequence, the 7-day moving average data from New South Wales on the 4th of August are relatively low. There was only 60 new cases out of about 21,000 tests. then the infection rate per test is about 0.000754. We're given the test accuracy is also 99%. Okay, we're using the same method, same spanning tree approach. What a probability you were infected true positive when you have been test positive in New South Wales on the 4th of August. Now, we do exactly the same things. We work out the false positive and the true positive cases. And it turned out to be about 0.01, just about less than 1, just more than 1%. So the probability you actually be infected, given the fact that you have been test positive, is less than 7%. That you are actually it showed positive, but you are not true positive about 93% of the time. So it's highly unlikely. Now, despite the test is positive, the probability infected is very low. The question is why? Because infection rate per test is very small and much lower than the inaccuracy of the test, which is about 1%. So in fact, if you look at the relative ratio, it's about the inaccuracy is about 10 times the infection rate. And that showed up the reasons that the infection that you are actually true positive is only 7% or less. So what did that mean? Out of 100 people who have been positive, showed positive, there's only 7 people actually are true positive. The other 93 people are false positive. So they will be very much alarmed. And the normally things they do is do a second test. Okay, so there's one positive, and the second test most likely turn out to be a negative. In that case, they will send them to see medical diagnostics, and the doctor will do some examinations and conclude whether there should be more testing done or otherwise. So that is the case where the effects of false positive is quite high. Okay, and the reason for this is because infection rate is much lower than the test inaccuracy. Okay, so let's move to the concluding remarks. So, as I mentioned before, the test accuracy, if it's 100%, then you would not have false positive, no false negative. But unfortunately, many the inaccuracies may be due to human error. So the method to do it is improve the training and improve the data gather and the correlation between the data and the persons. Okay, and if you have been test positive, the probability you are actually infected is high if the infection rate is compatible to the inaccuracy rate, as in the case of Victoria. Okay, so that is the case where the inaccuracy rate about 1%, and the infection rate is also high. The infection rate in this case is infected per show positive per test. Now, on the case of New South Wales, the infection rate is much lower than the inaccuracy rate. Therefore, the probability of actually get infected even after you've been test positive is much lower. So that's the case you've been unnecessarily alarmed. Okay, so you go back to a second test maybe next day or day after you receive the SMS from the test center that you are positive, come back for a second test. So with the interim period, you will be worried. Now, coming to the question, should we have universal testing? Okay, that's a question which have been raised many times. This is in order to catch the asymptomatic cases. People have no symptoms. Now, if you look at the same day result in Victoria on the 4th of August, instead of looking at infection per test, you look at the ratio of infection per populations. So ABC source gives some data, the infection per 100,000 Victorian residents. Okay, in this case, they show is 186 new cases per 100,000. Or the infection rate is 0.001862. Okay, now how does it compare? You compare with infection rate of 0.0155, and this is over test number. This is over the populations. Now you can see the difference. Now, in the case of the population, it's much more smaller. Okay, in fact, it's 10 times smaller because we show most people, despite the case, the pandemic situation, is healthy. So if you look at the number of cases detected over the entire population, the ratio will be much lower. Now, if you do the 100,000 people testing, then what will you find if the inaccuracy cannot be improved is many people you have been test positive are false positive. So universal testing is not only expensive, but is unnecessary alarming. Okay, so for that reason, we should focus testing on the vulnerable groups. So what are the vulnerable groups? The healthcare workers, the aged care workers, the elderly populations, people who have close contact with confirmed cases. Those are the vulnerable groups. We should do more tests and regular tests on those vulnerable groups. So this is what you can learn by looking at false positive cases. Now, with that remarks, I think we finished the talk today. So thank you very much for your time. I hope to see you sometimes.